Hello, everyone. And today, this Tuesday, is my turn to have a call the doctor session. And I thought to revisit one of the topics that I talked about back in the, let's see if this is workable. Yeah, probably this is a good one. Yes. So, but I mentioned, I think in September for my first call the doctor session. Unfortunately, I wasn't bad enough, so they decided to have me more. And so, I just flew through this HDF5 JSON thing, and I thought maybe I think it deserves more. So let's have this session about that and see how long it takes. So what is HDF5 JSON? That's the initially, I think the effort when I became aware of it even before I joined the HDF Group. It was 2013 that I became aware of the HDF5 JSON. It was really to create a JSON representation of a one HDF5 file content. And so right now that's still sort of the foundation of this, but HDF5 JSON found use over time in a couple of other software and technologies of HDF Group. So I think it's kind of a nice baseline or introduction to other to these other technologies. So what are the other technologies? One is HDF5 REST API. Parts of HDF5 JSON are actually payload of the HDF5 REST API. And the second one is cloud native HDF5 storage schema as implemented by the highly scalable data service of HSDS. It has a lot of similarities. Essentially is HDF5 JSON plus some other things. And so those two, and the third one, not very much known, is that project called HDF5 Product Designer, which uses HDF5 JSON as a transient file content description. What I mean by that, at some point when an content of HDF5 file has been designed or been done, or at any point, user of this HDF5 Product Designer could say, I would like to generate source code that would create me such HDF5 file. And what we were using, what we built tools around was HDF5 JSON. So if user chooses to do that, HDF5 JSON about that file comes out, and then there we develop tools that will generate MATLAB, IDL, and Python code that would actually, when run, create the file, actual HDF5 file. So that's another way where HDF5 JSON found usage. And also not only file, we also had the ability to generate Word documentation about the file content. Again, looking at the HDF5 JSON, you could get a Word document having sort of templated every group, every data set, and every other things in this file, ready for editing and filling the blanks or text. And so those were the things that that benefited from HDF5 JSON. So long story short, what is HDF5 JSON in abstract? Well, it's defined right now in two ways. One is, and this is the original definition of HDF5 JSON, using Backus-Naur grammar. And you could obviously go and look at these things. They're very specific definition. And that's the original one. And recently, I would say maybe about, generously, I would say maybe a year and a half ago, we actually have a JSON schema that basically defines the HDF5 JSON. Having JSON schema is beneficial because we could now run validation of HDF5 JSON. It not only benefits the community, it benefited us, because when we ran JSON schema on these examples that were even here on this documentation, we discovered quite a few differences, or shall we say design discrepancies or mistakes. And so that was very helpful in that way. Also, I think given how much HDF5 JSON found applications in other software, we could also probably look into this schema as a starting point to develop validation, for example, of HDF5 REST API payload, or maybe some even other things. But until, as I said, maybe a year and a half ago, this was not available, so we couldn't do this. So I'm not going to go through a specific definition of various things. I think that's a little bit too long. I can show you an example, and then hopefully you can go through it and see how it goes. So I'll switch and share something else. Let me share now another window.
Can I ask you a quick question? Would it make sense to deprecate the BNF grammar and completely switch to the JSON schema? I think that might be less confusing to people. If there's one way to standardize it, that's good enough. Every other way is one too many. And
fair enough. I think that yes, we could. I think BNF grammar was, as I said, original, and so as of now, it's still, I consider it still the source of truth, and only, when JSON schema happens, I'm kind of very careful to see if BNF grammar is kind of correct or not. But yeah, I agree. We should decide which one is one source of truth, and JSON schema may be better one because it is, after all, JSON and schema. So how we're going to do the examples? Well, first of all, I think, let me introduce the package. So when HDF5 JSON has been developed, and then maybe a second, third year after that, I think in 2015, 2016, I think we developed H5 JSON Python package. And the main reason for this was to achieve those two goals of HDF5, initial goals of HDF5 JSON. It is to take an HDF5 file and translate it into HDF5 JSON, and then also do the backward path, which is to take HDF5 JSON and generate HDF5 file out of it. And this is achieved by a package called H5 JSON. And it is available on PyPy, although we have not updated it in quite a while. So in my opinion, it's much better to use now the H5 JSON from the GitHub repository, which is this command that I'm now highlighted, basically, that you should run. And it has a lot more bug fixes, improvements, that kind of thing. So there are three commands right now that that this package comes from. There is a JSON to H5. This is when you have HDF5 JSON and want to create HDF5 file. There is the reverse, when you have HDF5 file and you want to get HDF5 JSON. There's this tool called H5 to JSON. I'll show it now. And there's the third one, after we got the JSON schema, H5J validate, which if you provide it with HDF5 JSON content, it should run and basically validate if that content is compliant or not. And it can work with a single HDF5 JSON file, or it can work with a folder full of HDF5 JSON files to sort of speed up the process. And so, as the example goes, here's the example. We're going to use H5 to JSON. and we can do help and see what it says. I don't know why it takes so long, but I have to say my laptop recently migrated to Microsoft 365, so it became a little slower for some reason. So yeah, you see, basically input is a file name, which is HDF5 file, and then there are two important flags. First one is -D, which suppresses all data output. In other words, attribute values and dataset values are not going to be included in the HDF5 JSON. And there is the -D, which only suppresses the dataset value. And this is only because obviously HDF5 JSON is JSON, and that means it's a textual representation of dataset data. And it can very quickly become quite large as a file. And so for those, most of the time when I'm using it, I use the lowercase d. So I want to not to have dataset data in my JSON. But let's see if we go heavy to JSON, then just do nothing, just straight up. And then I know here there's some, and I think classic, is the classic available? No. Let's see what ones we have here. We can choose anyone. I think anyone is good enough. Well, let's use this image. Let's see, example image. That sounds like something interesting. So the default behavior is that the output HDF5 JSON will go to standard out. So if I press this command, it's going to process the file and then output on my screen. There we go. And all you're seeing now is data because I didn't say suppress the data. So we're going to read it like that and see how it goes. See, quite a lot of data. So we're probably going to stop it. It's going to take some time. So what we can do, we can say, yes, we want attribute values, but we don't want dataset values. And you'll see now in this case, as you see, it's much faster and we get the JSON. And so because this is on the screen, I'll have to import it somewhere. And this is as good as any. And so I think hopefully we're going to get it from the, there you go. So now I'm going to just close this one. Yeah. So we can talk about the structure of HDF5 JSON and see how many we can close. There you go. So folding, I switched on folding. So hopefully, is this too small or you can see it on the screen? Good. All right. So the API version, this key or this property, I have to admit we have not really clearly decided how to use it. So it's still here. And we do increase these numbers occasionally, but right now we do not have really some strong heuristic attached to or semantic meaning to this API version value. But it is required, and JSON schema will flag it as an error if it's not available. But generally, the structure of HDF5 JSON is how you see it. You see the root property or root attribute, and there are two other properties or keys, whatever you want to call them, groups and data. And the root is very important because this is effectively an entry point into the other HDF5 JSON content, because root holds the identifier of the root group. And in the HDF5 JSON, at least with this Python implementation of it, we chose to use universal identifiers, unique universal identifiers, UUIDs. And so every object in the file, group or dataset or committed data type will have this unique UUID. And in the root one, this UUID that you see belongs to the root group. So the way how you would enter now is that you would open the group, and maybe let me just close this one. There you go. And so I here have only one group, but you could have more. And you would basically look for the UUID of the root group. And obviously, this is the one equal this one. So we know that this entry for this group is the root group in HDF5 file. And out of there, everything else flows. So one of the important features of HDF5 JSON is that it doesn't represent the hierarchy of the HDF5 file. Whenever I talked about HDF5 JSON, this was the most surprising feature, because people are so much mentally attuned to hierarchy in HDF5 that they get still kind of surprised when HDF5 JSON doesn't show that hierarchy right away, or actually doesn't have it. And the main reason for this is because in HDF5, the hierarchy is really sort of created through HDF5 links or by linking. And therefore, in order to support all the possible ways how you can have this linking hierarchy, you actually have to represent objects in an HDF5 file in this way. So you list them by what they are. The groups go under the groups key, datasets go under the datasets key, and if the file had a committed data type, there would be another top level key like this one called data type. And so all the other linking and the hierarchy in between all these objects is really embedded looking at each particular group. And so if we go here and look at the group, this is the root group, and obviously alias key gives you the sort of the path name of this group. And there can be more than one, because there could be more than one path to one HDF5 object. That's the multiple linking capability of HDF5. In this case, we only have one alias, and this is slash, so we know that that's the root group. And the links is what I talked about now. This is where now we're getting into these hierarchical connections, if you will. So links are HDF5 links in the root group that target some other object in HDF5 file. And there's four pieces of information here for each one. One is what kind of link it is, and you have a hard link, soft link, external link. You can have what is the type of that object that is the target of the link. So in this case, it's a data set. You could have other like groups or committed data types. Then here in the ID is the UUID, the identifier of that object. So if I would now trying to find this data set, I would use this identifier to look it up in the data under the datasets key. And then what is the title, or in other words, what is the name of this link? And so how would you interpret of this information in a more familiar HDF5 way? What I would say is that I have a data set in my root group whose path name is slash all data, for example, or that the next one is slash and land data, or slash and rainbow palette, that kind of thing. So let's say we want to look into this rainbow palette data. So how we would find it? Well, we would basically say we would look for something like this UUID. Let me use my editor for something useful here. All right, that's not the one. Let's see. There you go. So here it is. I found the entry for my data set. So let me close others so it's not too much confusing. So I close this one, and I close the other one. So as you can see on the data set, I now have my data set that I was looking for. again, remember how we don't have names here anymore? We have UUIDs or identifiers. But I know, looking from my root group, that the name of this, or the path name to this data set is /rainbow palette. And so now, when I open it up, as you can see, alias, it shows /rainbow palette as its name, as its alias or its path name. And now we come to more interesting things. So here we have attributes, we have creation properties, we have shape, we have type. So all these things now belong to this data set. And I failed to mention attributes can also appear for the group. Although in this case, we didn't have attributes in the root group, so we didn't see them. But generally, this attributes part can be equally appear in a group or in a data. So I'll come back to this later, but for the creation properties, this is the familiar things that you would find as dataset creation property list value. So again, this is what we read from the file and created here. Some are more popular, some are more esoteric. Obviously, allocation time and fill time is for the very specific people who like this kind of thing. For the average user, the very useful information is the layout, because what it tells us is that this data set is contiguous. It's not, could be chunked, could be compact. In this case, this is contiguous. Another thing that I failed to explain is that, as you can see, these values are mostly HDF5 constants as defined by the HDF5 library. So, although they do look very HDF5 specific, I think if you read them, it's easy to understand what they represent. So I don't think they're, so let's say, too opaque. They're definitely specific to HDF5, but I don't think they're so difficult to understand what they really represent. And so, so this is the layout, one of the creation properties. We go to the shape now. And here, as you can see, again, useful for users, we say that this is a simple data space. There are two others that it can be, null and scalar. And so the dimensions, this is the dimensions of the entire data set. It's shape. We see that it's two values, so it means it's two-dimensional. And we see that it's 256 by 3. It is a shape. If you had a chunked, then you would probably have a max dimensions here as well. But with this case, we don't have a chunk data. Type, this is the data type of the data set. As you can see here again, HDF5 constants, but they're kind of easy to understand. You can see this is unsigned, 8-bit, little endian integer. And so, and that's basically what information about the data set. Now, coming back to the, closing these things not to take up too much space. Going back to the attributes. Now, attributes to some degree repeat some of these components that we've seen in the data set, for example. So first one, we see shape, we see type. Those are very similar to what we saw with data set, in a way. The new one is name. It's a name of the attribute. So we know that we're looking here at the attribute name class. Those who are familiar with that name, we know that this data set is actually a dimension scale, but that's a bit advanced. Shape, here we see that it's a scalar value, attribute value. If it wasn't a shape, it wasn't a scalar, like it was again some kind of a simple data space, you would have information here about that. Type, we see that here we have a case of a string, and this is a fixed width string, length 8, and the value is palette. Oh, it's actually, sorry, so there wasn't a dimension scale. I forgot it. This is actually HDF5 image convention. So, so that's basically what information about a single HDF5 attribute looks like. And then obviously the next one is this one named PAL version. Again, it's a scalar. Again, it's a string. And we have this value 1.2 as a string value. So that's a data set with two attributes attached to it. And that's pretty much the sort of the big walkthrough through HDF5 JSON. I mean, any questions so far? I cannot see the chat or anyone. No one asked anything. So if there are any questions, please ask them now. So let's say.
Hey, Alexander.
Yes.
I have a question.
Yes.
The links, I know it's links and, or I recall now, links and attributes are lists rather than maps. Do you recall what was the motivation for that?
You mean like here that it's a list here?
Right. So like rather than have the title be a JSON key, you have just a list of items. And so if I want to find, say, a link called all data, in principle, I would need to iterate through all the links and look for that title of all data.
Excellent question. I mean, I think it's only, I guess, a design decision. Yes, it is. Yes, I mean that is one of the performance considerations, I think, because in this case, if someone consumes this HDF5 JSON, it would not be able to pull up something by name of attribute. I mean, again, it's purely my theory. I think the reason was because that's how things are done in HDF5, I guess, file.
Mm-hmm.
That you really have to go through all the links and look at them and find out about them. That you don't really store links by their name or anything like it. Right.
And I don't recall offhand, in HDF5, in the HDF5 data model, say, are links ordered or not? I mean, does the enumeration of your links matter or not?
I would say no. That's not specified. It's sort of more like implementation rather than data model.
Okay.
I mean, the C implementation certainly tracks the creation order. That's, I think, I forgot if the creation time or the name is the default index for links or also for attributes. But yeah.
I mean, creation time is a optional thing you can have on a link. And I think we had that in the JSON spec as a key too, the creation time.
Yeah, although not so much the creation time, it's really the creation order, because off the top of my head, the creation order that you can, the creation time, I think you can do that for groups and data sets and so forth. I'm not 100% sure if that's the case for links, because links don't have an object header, and those timestamps live in the object header. So I misspoke. There is no creation time, however, the order. And of course, if it were a map, then yeah, you couldn't retain the order.
Right. Yeah, and I think one of the things that might be confusing for people new to HDF5 is that the link is not the thing it links to, right? Okay. Links and, say, data sets have their own independent but related identities, right? So you have like the creation time for a data set, but the link to a data set could be created at any time after that.
Yeah. So we're running, this is the end of this thing. So for end, I deliberately mangled this JSON that I was showing. So we'll see if the if see if this validation thing will pick it up. Let's say I can say fj validate, and then see if how it's going to work, and then bed JSON. And I think this is going to throw up some errors. Hopefully. Yeah. Something else didn't work. All right, I haven't checked. Yeah, probably I should have reinstalled this in my developing environment, but it actually does work, at least when I was trying it before. So, but the idea is that that basically it will start throwing errors in the. Let's see if I can do this quickly. I'm already here. Maybe there's so many things I probably failed to do the, but we'll see. Maybe fixes it, maybe not. But anyway, the point of this validation was to obviously catch some errors. We'll see if it goes. All right. Okay, let's see, maybe. No, I have to look what's going on here. Anyway, it did work before, as always.
Hey, Fedor, are you in the right Anaconda environment?
I think so. But haven't ran it for a couple of months, so maybe I moved something around. There was a bug recently, several weeks ago, on the repository that someone had problems with this, and I installed it from the repository into a fresh new Conda environment, and it worked. So that's why I didn't try here before. I thought it just works well. I probably have to see what is going on here. Anyway, that's it basically. I have that much for this session.
It looks like you can find the schema. I mean, from the just reading the hour message. Yeah.
Yes, I tried to update the package so when you install it, it actually installs the schema as part of the package. And that was exactly the bug report from some user, and that's why I tried it in a fresh, new, clean Conda environment from installing it from the repository, and it worked for me. It was able to validate in all the others. So I have to see why it's here complaining or not. I have to understand this more. But maybe when I'm using it as a developer, maybe finding these things is not working as installing it completely as a user. You know, I'm not sure that these two things work easily with each other. But anyway, that's all. Next Tuesday will be someone else, and then I'll probably show up in December, I guess. I don't know how we are planning to do things in December. There's something in chat. Okay, thank you, Robert. And that's basically that. No more questions.
Maybe just to come back to John's question. I think the data model at that point is really ambiguous in the sense that, okay, a group is a collection of links. What kind of collection, it doesn't actually say. It only says that a link is sort of this unidirectional, single source, single destination association, named association at that. And that's it. Now, the library, the earliest implementation, implements them as B trees. So the links are managed in a B tree so that you can have very large numbers of links, very large link collections, and still be reasonably efficient in traversing groups and locating links and things like that. But then, you can always say, well, if I want to track certain things like creation order, creation time, although again, you can argue that's an implementation detail. Is the length creation order really significant? Sometimes, or perhaps, but it's something, that's in a way unspecified, or where an implementation can make choices, and the data model doesn't say, oh, you have to implement this as a B tree. Obviously, this representation doesn't do that, and there's just no guidance, let's say, or no recommendation, and so it's
I mean, that's one, again, if we're going to talk about it, that's one option, that maybe we update HDF5 JSON to have this kind of feature.
Yeah. I think at the time, thinking about it, in XML, I mean, looking for a moment at XML, how in XML, of course, you have much more generalized linking concepts. So again, this is the very special case of a single source, single destination link. And the source, the implied source here is, of course, the group that hosts this collection. But in the X-link standard, for example, in XML, you can have links with multiple sources and multiple destinations. And in that context, so the title, if you wish, this sounds a little bit like a GUI application or something like that, if you wanted to traverse or to render such a link visually, then the title would be sort of that attribute where a GUI application would go and pull out that name. Now, that's of course not an argument to say this couldn't be a key, because in the JSON sense or in the map sense, we in a way we never supported and perhaps will never support multiple source or multiple destination links. And but should we ever want to one day, then maybe making the link name the key may not be such a wise thing to do. So in that sense, maybe it's a historical artifact, or it's a
Yeah.
One thing that I thought about is the kind of SKUID ID we use. So when you first convert HDF5 file to JSON representation, of course, the file doesn't contain these GUIDs, right? So they're created on the fly from just as basically a random GUID. So in HDF5, datasets and groups have an ID, but it's a numeric ID. I guess it's just like an offset in the file to the location of that object. And I don't think it's purely immutable either, right? It could change over time, possibly.
Yeah, and it is really, I mean, if you look at the vol specification, for example, that's why we introduced these tokens, for example. Yes, for native HDF5 files, but only for single file layouts. The offset in the file was that address or that identifier. But even already for multi-file layouts, that in a way breaks down because it's, I mean, what the VFD does is really map a logically linear address space into a physical address space that could be the union or some kind of aggregate of combinations of physical files in some shape or form. And so that's where these limitations show. And then, for example, that's why in Vol, this was a more general token. If you target a storage like Deos, for example, well, the offset, there is no offset in a file in an object store. And so that's why they introduced these tokens that, in corner cases can be addresses or can be interpreted as addresses in a file. However, more generally, they are just tokens. I mean, it could be also like the hash of an object if you have a content addressing based store. You could just take the hash of the thing that you want to address and as that identifier.
Right. And you know, the thing about this using the file offset, even for the native driver, is that if you say rechunk a data set or something like that, you have, you know, conceptually the same thing, but now that offset could very well be moving around. So I would like to see in as we talk about HDF5 2.0 have some kind of vision of how we manage these IDs. Because, you know, the thing about HDF5 is naturally the H5 path to an object is not the canonical ID of that object, right? You know, for one, you could have multiple paths to the object, and for two, you could very easily be moving links around, renaming links, but you still have the same object. So I think having a better concept of the identifier for an object would be a good thing.
I'm not so sure, because the ID, I mean, this ID is really it's sort of a it's sort of a hodgepodge in the sense that, and I mean, when Aleksandar early on talked about, well, what is the purpose of HDF5 JSON? In one way, it's a description language for HDF5 stuff, speaking roughly. And at that level, they are just they are just tokens. They are just identifiers that we make up that have no meaning, that have no particular meaning other than the function to identify something. Now, if you then take that to a specific implementation, of course, there will be a correlation, so to speak, between these identifiers and address offsets in a file, Deos keys, or but in some cases you can then substitute. You can say, well, I don't need these abstract identifiers anymore because I have specific representation and it's one-to-one, so I don't lose the uniqueness. And but I think that's where it gets tricky. And as long as that exposure, so to speak, is there, that in practical circumstances, the rubber hits the road somewhere where you have this problem. Do I maintain that fiction of these meaningless abstract identifiers, or do I see potential for optimization and then get into the habit of interpreting or trying to give meaning to these identifiers? That's where it's sort of, but that should be in a way ideally kept away from users, so that they don't start doing things that they don't fully comprehend or appreciate. It's so to me, the UUIDs, they are really just meaningless identifiers. They are just placeholders or tokens.
You know, one challenge that comes up in practice with the H5 JSON package is this: if you take an HDF5 file, converts JSON, think that JSON converted back to HDF5 file, well, you get sort of pretty much what you started with. But now if you take that same file and convert it to H5 JSON again, there's a bit of artifice to get those goods to match up. the second time we do it. We actually store the GUIDs as an attribute, I believe, in the group, which is kind of a hack. But otherwise, the problem is you every time you translate, you get something that's not exactly the same because the GUIDs.
Yeah. I think in some incarnation of these tools, there was actually a way that you could store the mapping externally so that you wouldn't drag it into the file. And then the tool, if it saw that such a mapping, such a lookup table at the end of the day was available, rather than generating new UUIDs, it would use the lookup table present. And yeah, so yeah, that is a cosmetic defect that, yeah, you want a consistency loop, so to speak, and it in a way, yeah, is a cosmetic defect that loop is not perfect potentially. So.
Yeah, maybe next time I'm hosting this, we could do a look at the HSDS format because it's similar and different in some ways. And that might be an interesting discussion.
Yeah.
All right.